Hello everyone, I am Dr. Nitin Kumar Saxena. In this chapter, we have seen till so far in our previous videos that how can we find how can we evaluate the current and voltage in any circuit having the resistances, and also how can we find the equivalent resistance for any circuit. So now we will start in this chapter with the concept of electrical energy and power. So to understand this topic, let's have a conductor having the two extreme surfaces A and B, and a voltage source is connected across it. Okay. So what will happen when this voltage source is connected across this conductor having the extreme surface A and B? So an electric field will be produced and a current will start to flow through this conductor. The current which is flowing through this conductor, so what will happen? Since current is flowing in this direction, so we can say the negative charge particle electron will move from the surface B towards surface A. Right. So when it is moving from the surface B to surface A, if I am saying the potential value at surface B is B, the potential value at surface A is BA. So this electron has to move from the surface B to A against this potential difference. Okay, in other words, if I am saying in general, and del Q, you say, if I am just saying in general, a del Q is a charged particle which is moving from one surface to another surface. So, the potential energy, so we can say potential difference is VA minus VB, and the one important point is that I have told you in previous video that current always flow from higher potential to lower potential. Since current is flowing like this, so this simply indicates that VA is more than VB, right? So the potential at point A, at surface A, is more than the potential at surface B. So potential difference is given by the formula VA minus VB. So if I talk about the potential energy of this charged particle del Q, that can be defined as del Q into, it's moving from A to B. So what would be the potential difference? We will put here, the work done will be to move from A to B can be given by this formula. Okay, or since I know that here this is positive, so I can put like this also. Alright, or in simple words, I can write it like, since I know the formula that I is given by del Q over del T. So this means del Q can be written as I del T. Right, and for this BA minus BB, I am putting a single potential. Yes, the difference between the potential is same as this, because this is applied across this surface, and in my previous video I have told you that this potential will appear across the surface A and B. So this means VA minus VB will be V, and hence del Q multiplied with V. Again minus, what is the value of this? I del T, so I can write like this. Okay, so in place of del Q I am writing I delta T. So I delta T into V, rearranging the terms, I can get minus IV del T. So this is the potential energy for a charged particle which is moving from extreme surfaces of the conductor. Now you see, if I am assuming that there is no other charged particle, this is the only charged particle. So what will happen? If there is only single charged particle, so we can assume that when it will move from surface A to surface B, there will be no collision. Okay, so if there is no collision, so whatever the energy this charged particle has here, it is in the form of potential energy. And finally, when it will reach to the surface B, so what will happen? The whole potential energy will be converted into kinetic energy. So I can say yes, the kinetic energy, when it is reaching to the next extreme, here it is reaching from A to B. So this kinetic energy will be, and since all the potential energy is transferred to kinetic energy, so what can I say? This is, if I am denoting it by del U, so that I can say del U, and this kinetic energy can be denoted by, say, del K. So what I get? I get del K is minus del U. Okay, change in kinetic energy, this is change in potential energy. So what is change in kinetic energy now? If I put here, so VI del T. Okay, so this is the energy which is stored in the charged particle when it moves from A to B. But if we see any realistic condition, so what will happen? In real condition, there are number of electrons or proton or nucleus inside this conductor. So what will happen? The energy, if this conductor is assumed that there is only one charged particle, so when it will reach to this plate, it has this energy, kinetic energy. But since it is colliding in real with other charged particles, so what will happen? It will reduce its energy in the form of collisions. Okay, so when collisions will take place, so they will collide, they will lose their energy, and this energy will be dissipated in the form of heat. And hence, we can say this energy of kinetic energy, the same except the sign convention. So if there is no collision, so this will be the kinetic energy with this charged particle, but since there is no number of charged particles are available in this conductor, so this energy will be dissipated in the form of heat from this conductor after the collisions, and this energy can be dissipated to the atmosphere in the form of heat. Okay, so it will reduce this energy in the form of heat. So we can say that the heat dissipated is same as, if I am taking the extreme condition that all the energy is dissipated in the form of heat. Okay, so because conductor has no mechanism to store the energy, whatever energy is coming to conductor, that should be dissipated to the atmosphere surroundings, right? So this all heat dissipated will be same as the energy previously in the form of potential energy, and maybe if there is no collision in the form of kinetic energy, and hence this is called Bi delta T. And this heat dissipated by the conductor is known by the electrical energy. Okay, so this electrical energy hence can be defined as Vi delta T. Okay, so this is the electrical energy which is either in the form of initially potential energy or maybe in the form of kinetic energy finally, but this all energy, because of the collisions which are taking place in this conductor, will be dissipated from the conductor, and this dissipated energy is given by Bi delta T, which is known as the electrical energy of the conductor. And hence we can say that yes, any conductor has the electrical energy which is equal to Bi delta T, and the whole energy goes to the atmosphere surroundings in the form of heat, right? So finally I can write here that electrical energy is Vi del T. So in del T time, how much energy is dissipated? Is this. Okay, so the energy or heat dissipated in time, suppose T. Now I am saying in place of this del T I am writing T because I have derived for the small interval. Now I am looking for the marginal interval, so good interval, big interval we can say. So the energy or heat dissipated in time T from any conductor is called as electrical energy, right? Electrical energy. And if you see, this is energy, so what is the unit of energy? Joule. Okay, so what is the unit of electrical energy? Is given by joule. Normally we define it by the symbol of either V, or in other some textbook you will get like this, VIT joule. Okay, so now if you know this is the statement or expression for the energy, and for how much energy dissipated in T time is called the energy. Now if I want to know that what is the energy dissipated per unit time, so that will become your power. So power is defined as, so power is defined as the energy or heat dissipated per unit time. So what is power now? Power is VI, because power is energy per unit time, so VI, and its unit will be joule per second, and in short it is called watt. Okay, so the unit of power is watt or joule per second. So if we know that how much energy is dissipated per unit time, we can get the value here, VI. Okay, normally you have seen that we have the electric meters at our home, and they give normal practice. We say that okay, we have consumed 100 units in this month. So what does it mean? So this, what electric meter shows at your home, this is also very interesting thing. So electric meter that is generally used for measurement of energy consumed at home. Okay, so electrical meter that is generally used for measurement of energy consumed at home gives reading in you see, from here you see, if I am saying the unit of power is watt. So what is the mean? What this means? This means this we are defining by watt. Okay, and this is time. So the another unit of energy may be watt into second. Okay, this is for watt and this is second. So the another unit of E is watt into second. If I make the unit big, so in place of watt I can write kilowatt, or in place of second I can write hour. So I am doing some big readings only. Means we are taking some big units for this watt. We are replacing with kilowatt and this time second with hour. So gives reading in kilowatt hour. Okay. So generally used for measure for energy consumed in at home gives reading in kilowatt hour. This kilowatt hour in common term is called unit. Okay, in common term we say that this is unit. So this means if I am saying that the my electricity bill is 100 unit. Okay, so I am giving you one example. If I am saying okay, if I am saying that the electricity bill for a house is suppose 200 unit. Okay, the electricity bill for a house is 200 unit. How much energy is consumed? How much energy is consumed? So this means if bill is 200 unit, so simply this means energy consumed is 200 kilowatt hour. Okay, because this is unit is kilowatt hour. So this means total energy consumed, which is shown in the bill, is 200 kilowatt hour. Okay, if in other way, let us do in one more example. I am saying, okay, if a bulb of 100 watt is used for 30 days in a house, what will be the electricity bill? Okay, so the question is, if a bulb of 100 watt is used for 30 days in a house, what will be the electricity bill? So I can do like this. Okay, if a bill of 100 watt is used, this means for 30 days. Okay, so energy consumed E, you know this is given by PT, right? So what is the power consumed? 100 watt, right? And for how many days? 30 days. So if I do like this, so what, okay, I'm writing like this, 100 watt and 30 days. So I have to calculate the electricity bill in terms of unit. What is unit? Kilowatt hour. So what I will do, I'll change this watt in kilowatt. So 100 upon 1000, this will give you kilowatt, right? Multiplied with 30 days. Okay, one day has how many hours? 24 hours. So this means if I want to change this days into hours, so I have to multiply it with 24 because one day equals to 24 hours. Is it fine? So this means I can write 30 days equals to 30 into 24 hour. Both are the same thing. So this is equals to this and this is equal to this. So when I will solve this, so what I will get? Okay, so this means if you are using the bulb continuously for 30 days, so at last how much unit you are consuming? You are consuming 72 units. Hence 72 units are consumed in 30 days. If this 100 watt electricity bulb is continuously on for the 30 days. So I hope the concept of energy and power is clear to you. We can do one more thing in this concept, that we have given you the formula for P as VI, and since I know that Ohm's law says V is IR, so if I put the value of V, what I will get? I square R. Okay, if I put the value of I, so what I will get? V square IR. So simply, we have the formula P equals to VI. So from this formula, if I put the value of V, IR, so IR into I give you I square R. If I put the value of I is V upon R, so when I put V into V upon R, so that will give you V square upon R. So this means power can be given by any one formula, and in the same way energy can also be given as VIT or I square RT, V square upon RT. Okay, so any one formula can be used to calculate the value of electrical energy. At the same time, any formula can be used to calculate the value of power in a circuit. So I hope the concept of power and electrical energy is clear to you. Now let us move to the other concept of cells. Another concept of cells. So what is the cell? And what is the role of cells in any electrical circuit? I have told you that we have some electrolytes, and that how can we make an electrolyte? By simply having some jar in which we can pour two electrodes, okay, and we can place some liquid in it, okay. This arrangement is known as the cell. Okay, so what is cell? When we are putting two electrodes in an electrolyte, so in a jar, jar is filled with this electrolyte, then this is called the cell. And now if I am saying, you see, if this normally say this two rods. One rod is normally called cathode, another is called anode, and the cathode has negative charge and anode has positive charge. So what will happen when we connect this circuit with any external circuit? Suppose I am saying this is external circuit. Okay, suppose I am saying this is R. So what will happen when you will connect this cell with this external circuit having a resistance R? So this circuit is complete. Now the current will start to flow from this A, will go like this, will come like this, and here the charge particles will move between these two plates, A and B. Like if I am saying the current is flowing like this, current is going like this. Okay, so here it will go like this, right? So what we can see here, that the current means, and if this is the direction of current, means current always flow in the positive charge particles. So if I talk about the electrons, so what I will say, I'll say yes, electrons will move like this. So this is the direction of electrons, this is the direction of current. And since the substance is filled between these two electrodes, so when these electrons will move from A to B, there will be some reluctance, some resistance in the flow of this electron, and this oppose of the flow of electron from the surface A to surface B means that there is some resistance between A and B, and this resistance is called the internal resistance of cell, and normally it is defined by small r. It is defined by small r. Okay, so I hope the concept of internal resistance is clear to you. When we connect the electrodes with some external circuit, so what will happen? The current starts to flow. To complete this circuit, when it is going like this, green directions, so from the plate B and plate A, this will come like this to complete the circuit. And since the current is flowing in this direction, electrons will flow from A to B. And since some substance, some material, some liquid is filled between the plates, between the electrodes A and B, so that liquid, that electrolyte will oppose the flow of electrons between the plates A and B. There will be some collisions and all. So they will lose some energy in that form. And hence, we can represent it by some internal resistance. And this internal resistance is what? Can be given by the simple term R. Right? So you see, if I am saying, yes, the potential between the surface A and B, potential between surface, between what surface? Electrodes A and B is VA minus BV, which can be defined as V, right? So you see, what will happen here if I am saying that this AB is connected with two circuits, one cell circuit, one external circuit. So we can say there are two circuits. Number one, internal circuit of cell, right? And second is external circuit with cell. This is fine. If I am saying the potential between these 2 points A and B is given by B, and suppose a current I is flowing in the circuit, okay, the value of this current is I, every. right? This I have already written I. So you see this resistance has a current I. So what is the value of this V here? So V will be IR. Sorry, V will be IR for external circuit, right? For internal circuit, V will be, you see, if I am saying the potential between the potential developed by this cell is E, the potential developed by this cell E, or in books you will get this some symbol also. So either you can use this or capital E, that's up to your choice. So I am using the convention which is given normally in the textbook. So if I am saying the potential developed by this cell is E, but this potential will drop down because of this own internal resistance. And how much it will drop down? This will drop down like this. Okay. So this means this is the formula. This is the formula that the potential developed by any cell. So how much potential is developed by cell can be calculated by this formula. E is the electric field between the plate A and B, right, which is normally known as VA minus BV, higher minus lower, higher potential minus lower potential, C plus minus, so higher potential minus lower potential. So this value is given by E minus IR. And if it is connected with an external circuit which has the resistance R, so the external resistance potential is given by V equals to IR. So if I compare both the equations together, so what I will get, if I compare the equation this and this, so I will get E minus IR is given by IR. So E will be I times R plus R. So I can be given by E upon. Okay, so this will be the current which will flow in the circuit, any circuit which is connected with this cell. Okay, so normally what we do, we simply denote like this. Okay, so this whole circuit which has one cell which is connected to this external resistance R can simply be denoted by this simple arrangement, in which a cell with the cell with internal resistance R and EMF of the cell, electromotive force of the cell, and this R is called internal resistance of the cell. Okay, so this is the EMF of the cell, this is internal resistance of cell. Okay, so this simply can be represented by this, and if you see, since this is the positive plate, this is the negative plate, so voltage across these 2 points can be written as BA minus BV. Suppose I am saying this A, this is B, so this can be written as BA minus BV, or I am simply saying this is B. So what is here? I can write BA minus BV is B, right? And what is V? V can be written as, from positive to negative, E minus IR, right? And you see, if I want to flow the maximum current, this is the formula of the current which is flowing in this circuit. Okay, so if I want to know what would be the maximum value of current that can flow to this resistance, that is given by this formula if I put R equals to 0. So in that case, I will be this, and this will be the maximum current that can flow in the circuit. So I hope this. Hello everyone, I am Dr. Nitin Kumar Saxena. In my previous video, I have discussed with you the concept of EMF of any cell, and we have seen that if we are talking about any cell, so cell is normally represented like this, which has one plate bigger and another one is smaller. Its EMF is given by value E and resistance internal is given by small r. So if it is connected with any resistance, external resistance R, so the current flow in this circuit is given by E upon R plus R. If we want, if maximum current flows, or you can say maximum current flows when internal resistance is 0. So the ideal condition is that the internal resistance of the cell should be 0, but it is not practically possible. So practically we denote some internal resistance of R, and hence this is the maximum current that can flow through any cell to any external resistance R. But the real current always is very less compared to this maximum current because of this internal resistance of the cell. Okay, so now we see the next concept. If we are connecting these cells in different combinations like resistance in either in series or in parallel, so what will happen? So let us see. First, let us see for two cells. Let us start with two cells. These two cells has values like this. Means the cell 1 has internal resistance R1, second has internal resistance R2. EMF of first batch cell is E1, EMF of second cell is E2, and so what will be the equivalent? What will be the equivalent value of voltage and EMF and internal resistance if I represent this circuit with this circuit? So what will be the value? Okay, so what I am doing, in place of two batteries or two cells, I am replacing these two batteries or cells by a single battery or single cell. So if I do so, what will be the value of E equivalent and R equivalent in terms of E1 R1 E2 R2? So that is called the series connection for cell. So to drive this, let us start with, okay, I am saying this is a point A, this is a point C, and this is a point B. So similarly, this point will be A, this point will be B. Is it okay? So from the last discussion, we will find that what is the value of VA minus VC? So the value between VA minus VC, in last discussion we have seen E1 minus I R1. Suppose I am saying a same current I is flowing here like this. Is it okay? Or we can say, sorry, the current will flow. How the current will flow? The current will flow like this. Because I have already told you that when this battery is connected with any external circuit, so in external circuit, like I am again drawing it, so current flows like this. So positive plate to negative plate, for positive plate to negative for external circuit. But inside battery or cell, or the third name is voltage source, negative to positive. So this you keep in mind that inside the voltage source, this is voltage source or battery or cell. Inside this, it will flow from negative to positive, and hence I am showing from negative plate to positive plate. So this is clear. Now see the value between VC minus VB, E2 minus IR2. Right? So this will be E2 minus IR2. Now if I want to know the total value, what I will do, I will add these two things. So if I am adding, so this VC will cancel out. What I will get? I will get E1 plus E2 minus I R1 plus R2. Right? This is fine. Now the same thing I am doing for this equivalent circuit. So in equivalent circuit, VA minus VB can be given as E equivalent minus I R equivalent. Now compare this equation, or compare this equation with this equation. What you will get? When you will compare, so you get E equivalent is given by E1 plus E2 and R equivalent is given by R1 plus R2. And hence, what we can conclude? We can conclude that if cells are connected in series, so we can replace the cells simply by adding the value of EMF and by adding the resistance, internal resistance of the battery. Right? If suppose I am saying, okay, this battery is reversely connected. If this battery is reversely connected, then what will happen? So I hope this is clear. So I am taking a new case in which what I am saying, yes, here the battery is connected like this, E2 R2. Okay, so if battery is connected in reverse direction, so what will happen? You see, the difference will come only in one thing, which is the battery, the voltage source. Okay, the rest thing will remain same. Okay, so why? Because you see the current is flowing from B to C. So what I will do here, I'll change the magnitude of E2 only. So if I am changing the magnitude of this only, so what will happen? Because the current will moving is in this direction, so this will be minus E2 here only. So this will come. So you can say why the direction this is not becoming the positive, because you from the knowledge of KBL and KCL we have seen that if the current is flowing this, so we will take only the IR2, and the current always flow in resistance from higher to potential. So whether we put this resistance here or here, the same current will flow through this resistance, and hence we will use the term in place of E2 we will put minus E2, rest things will remain same, and hence there we will get minus E2 and here we will get this. Okay. So in general we can say that we will only add the EMF of the different cells and add the resistance of different cell, then we can get the overall equivalent resistance, internal resistance and equivalent EMF for the cell. So let us write a generalized formula. So how can I write a generalized formula? I can write like this. Okay. If I am saying okay, this is the combination E1 R1, E2 R2, E3 R3, or I can write like this, E4 R4, E5 R5, En Rn. Okay, and now I want to replace the whole circuit with this equivalent to R equivalent, right? So what is the value of equivalent here? E1, E2, E3 till En, and what is the value of R equivalent here? R1, R2, R3 up to Rn, right? This is clear. If suppose I am saying this battery number 3 is connected in reverse order, so you see the batteries which are connected in the direction of the polarity which is shown in the equivalent circuit, like left side we have positive value, positive plate, right side we have negative plate. So if they are connected in this way, like E1, E2, E4, these all are connected in this way. So these all we will take as positive. But since third battery is connected opposite to the polarity of equivalent battery, so we will take it negative. And hence, what you will do here only, you will change the sign if it is connected in opposite direction. So I hope the concept of the batteries cells when they are connected in series is clear to you. Now let us move when they are connected in parallel. So what will happen? So let us draw first. Again, we will do it for the two cells first, and if we understand the concept for two cell, we can go for generalized value. So again I am saying like this, okay. Okay, so I am saying yes, and the equivalent circuit is given by equivalent R equivalent E1 R1 E2 R2, right? So again the current is flowing like this. Suppose this is the current I, the same current I is flowing like this. Now what will happen? Since these two batteries are connected in cells are connected in parallel, so this current will distribute like this, I1 I2, right? If I am saying this is A, this is B, again this is A, this is B, right? So you see here, you see that now try to find the value like the previous case. How can we find? Okay, so let us start with this first circuit. So for this first battery or first cell, VA minus BV is given by E1 minus I1 R1, because the current is now I1. So E1 minus I1 R1 between these 2 points, because these 2 points are same as these 2 points. These are the equipotential points. So whether I write this minus this or this minus this, the same thing. Similarly, BA minus BB for the second case is E2 minus I2 R2, right? Because now the current in this R2 is I2, so I will write I2 R2. Now you see LHS is same for both the cases. So if I compare both the equations, so what I will get? I will get E1 minus I1 R1 equals to E2 minus I2 R2, right? So I get like this. This is clear. Now this is the equation number 1. In other words, if I want to know the value of I1, what can I do here? I1 will be, suppose for some time, this VA minus BV I am taking as V. So what is the value of I1 here? If you solve here, okay, I am solving it here. So VA minus BV, I am putting V. So V is E1 minus I1 R1. When you solve this, so I1 R1 will be E1 minus V1, right? So what is I1? I1 will be E1 minus B, sorry, not 1, only B. E1 minus B upon R1, right? So similarly, what will be the value of I2? When I will put VA minus BV here, so I will get E2 minus V upon R2. So this is the value of I1, this is the value of I2. And you know that from this side, I can see this, that yes, I is given by I1 plus I2. So if I put the value of I1 here, so E1 minus V upon R1 plus E2 minus V upon R2. Okay. So what I am doing? First I find the value between the VA minus BV, since I am putting VA minus BV equals to V. So solving and getting the values of I1 from this equation, I2 from this equation, and now from this expression we know that I is given by I1 plus I2. So simply I am putting the values of I1 and I2 here. Now you solve this, so what you will get, E1 upon R1 minus V upon R1 plus E2 upon R2, V upon R2, right? Now again you can write like this, E1 upon R1 plus E2 upon R2, right? Minus common, or we can say 1 upon R1 plus 1 upon R2 into V into. So this is the final expression of the current which can be found by this circuit. The same value of current we will try to find for this circuit. Okay. So I hope up to this point is clear what we have done so far. VA minus BV for this circuit, VA minus BV for this circuit, these two equations. Now put VA minus BV equals to V, and from this equation and this equation try to find the value of I1 and I2. Once you know the value of I1 and I2, what you will do? You will substitute in this expression, which is I is I1 plus I2, and you solve in this way, so you will get this value of I for this circuit. Now same thing we will try to find for this circuit. So for this circuit, again I am writing the concept of cell, that VA minus BV is given by E equivalent minus I R equivalent, right? So what is VA minus BV? V is E equivalent minus I R equivalent. So what is I now? When you substitute this, so E equivalent minus V upon R equivalent. This is okay. So you compare this with our expression. So E equivalent upon R equivalent minus V times 1 upon R equivalent. This is the value of I. Okay, so this means if I compare this with this expression, finally what I will get? I will get that yes, this E equivalent divided by R equivalent, okay, E equivalent divided by R equivalent can be given by the sum of ratio for each cell, E1 upon R1, E2 upon R2, since R2 only, and the value of resistance overall can be found by this formula. Right? So in this way we can find the value of equivalent EMF by this expression and equivalent resistance by this formula. Since we know the value of R equivalent, we will put here, we will get the value of E equivalent. Okay, so this is the formula when the cells are connected in parallel. Now what will happen if we go for the generalized formula? So let us try to write a generalized formula. So for generalized formula, what we can do, suppose this is E3R3, ENRN. So there will be I3, IN. So for this circuit, same E equivalent upon R equivalent. If I am replacing this circuit with this circuit, so if I am replacing this circuit with this circuit, E1 upon R1 plus E2 upon R2 plus E3 upon R3 plus and so on, last En upon Rn. And the equivalent resistance 1 upon R equivalent is given by okay, so in this way we can find the overall equivalent value of resistance and overall equivalent value of EMF if we have number of batteries, number of cells in parallel connections. Okay, and the same concept here, you see the polarity is like positive here, positive in left side, negative in right side. So all are connected in this way. If suppose I am changing for this, how I am changing? I am changing like this. Suppose E2 R2. So since the polarity of E2 is different from the polarity of your final equivalent resistance, so what you will do, only this negative positive will be changed by negative. Okay, so except the things will remain same. So I hope the concept of the combination of cells, whether they are in series or in parallel, is clear to you. Now after this, let us move to the next concept,